Unit 1 Chemistry, Chapter 7, Part 3, Intermolecular Bonding in Non-Polar Molecules now. So, we're still looking at covalently bonded molecules. So the bond holding the atoms together is still covalent. But some of these molecules are non-polar. Okay? That means that either the bonds are non-polar because they're evenly shared, okay, which might occur in something like O2 because they're both oxygen, so they've got the same electronegativity, so there's going to be exactly equal sharing. Also occurs if you've got a carbon-hydrogen bond because the electronegativities of carbon and hydrogen are very similar. That's one you just need to remember. Okay. They also occur when we've got an uneven sharing of electrons in a bond, but the molecule is entirely symmetrical in all directions. And if it's symmetrical in all directions, quite often we see this in a tetrahedral shape. If every atom around the tetrahedral is the same, well then that's not going to have an overall positive or negative end. So they can't have a dipole-dipole attraction because there's no dipole. What we can have is something called dispersion forces. You might sometimes see them called van der Waals. Okay? These are really weak. They happen because electrons move. And because electrons move, we might at any one time have more of the electrons over this side, which means we've got fewer over there. So in that instant, just for that fraction of a second, this end here is a bit more negatively charged and that end there is a bit more positively charged. The molecule that it's next to, if we've got a negative charge over here, that's going to repel the electrons from there. So that's going to induce or cause a dipole in the one next to it, which means we're going to get a little force of attraction for a microsecond, probably not even. Okay, so this is it distributed evenly, no dipole, but just in an instant we would see slightly more electrons over here, slightly fewer over there. This is an instantaneous dipole. It's going to go away again really quickly. Okay, but while it's there, we've got a slight negative and a slight positive charge, and that can attract to a neighbouring molecule. This is the only type of bonding we see with the noble gases.